Okay, hello. Today we are going to be discussing about free radical substitution, which is free radical substitution is a type of reaction that will be converting alkanes into haloalkanes. For an example, we're going to be taking 2-methylbutane plus Br2 and going to be converted into 2-bromomethylbutane, which is a type of haloalkane which we wanted over here. So free radical substitution consists of three steps. The first step is initiation, second step is propagation, the third step is termination. Let's look at the first step, which is initiation step, where we take the Br2 over here right down to here. So the Br2, if we look at over here, it will undergo homolytic cleavage, which homolytic cleavage means pemutusan sama rata. If you take a look at the Br2 over here, it has a covalent bond, which as we learned, covalent bond consists of two electrons, one is here and one is here. So the electron at here will go to this side and that electron will go to that side. This process, this homolytic cleavage will happen under UV condition where the CH2Cl is used as solvent and the UV is used because it provides energy to break this covalent bond of Br2, producing free radicals of bromine. Free radicals is a type of atom or molecule with unpaired electron, so that's why they are very and highly reactive. If you don't want to draw it like this, you can also draw it like this. Now, it's the same thing. For the second step, we have propagation step, which propagation by direct translate is spreading. So in this propagation step, we actually just want to perbanyakkan free radicals. So we take our 2-methylbutane over here. I draw it in the condensed form here to make it easier for us to see. And this 2-methylbutane, we're going to be reacting it with Br free radical, which we got from the first step over here. So you need to understand in this propagation step, we are going to be reacting between unreactive, reacting with reactive. So in this case, we have unreactive over here reacting with reactive free radical. This will produce reactive, this, and HBr. If you take a look over here, what is going on with the arrow? So the electron from the Br will be going to this side, while again we have a covalent bond over here. As we know, covalent bond consists of two electrons, so here are the electron. So the electron from here will go to this side, and electron from here will be donating to C, the carbon over here. Thus, this product is formed. Look at here. This one comes from here. This product will be formed, and HBr will also be formed. So it's the same thing over here. We take the Br2 and we're going to be reacting it with our product from here, thus producing again this one and our haloalkane. If you are wondering why did we use Br free radicals over here and why did we use Br2 over here, it's because as I said in the earlier, as I said earlier, we need to be reacting unreactive with reactive. Thus, the reactive in this case was this one. The reactive one is this one. Moving on to termination step, which it's different from this one. So this termination step where we will going to be reacting reactive with reactive. This one unreactive and reactive. This one reactive and reactive. So the reactive that we're going to be reacting is free radicals. So this termination step is actually used as endpoint to end the whole process. So the Br2 is the Br2, the Br free radicals. Br free radicals is going to be reacting with another Br free radicals, producing again Br2. Sorry. And this will going to be reacting with this, producing this, our major product, which is and then this one is going to be reacting with this one, producing our product over here. So if you take a look at this one, it's really similar to what we have in the beginning. which is BR2. So if you are thinking like, can we use this one to restart or reinitiate our whole process? We cannot, because this product over here is um, the product over here is low radical concentration than this one. So we cannot use this one to restart the whole process. That's why this termination step is called endpoint, because we cannot use the product to restart the whole step. That's all. Bye.